In section 3.1, we're going to be solving systems using graphs. This is one of those lessons that we're going to be using our graphing calculator for, so I would get that out now. When you have two or more related unknowns, you may be able to represent their relationship with a system of equations. And we call that system a linear system when all of the equations are linear. So basically that means you don't see any exponents on any of your variables. With that, a solution is a set of values that make that system true. So what we're going to focus on today is how to interpret that using a graph. So if I had two equations, the solution of that system would be where those two lines intersect. Another way you could also look at this, which you're probably not going to use as much, but if you had a table of values and it showed you the values for one equation and the other equation, if you see the x value and then the two y values matching up, that's another way that you can see a solution to a system of equations. So let's run through this with an example. I want to find the solution of negative 3x plus 2y equals 8 and x plus 2y equals negative 8. So as I said before, in today's lesson we're going to focus on solving by graphing. Later in this week we're going to focus on doing this algebraically. Today we're just going to focus on graphing. So if I'm graphing, the easiest way to do this is going to be to get my equations into slope-intercept form. So what I'm going to do, I'm going to start with my first equation. Remember, to get to slope-intercept form, that just means to really isolate that y variable by itself. So I'm going to add the 3x over. And then I'm going to divide everything by 2. And I'm left with y equals 4 plus 3 over 2x. Notice how when I divided 2, I divided it by 8 and by 3. I'll leave that up there. And I'm going to do the same thing with my second equation. I'm going to move x to the other side, divide everything by 2, and I'm left with y equals negative 4 minus 1/2 x. So these are my two equations, and I'm going to focus today on solving by graphing. Now with this equation, or this system of equations, I could easily probably graph this by hand, but for today I want us to get confident with graphing in your calculators, so that's what we're going to do here. So I have my calculator out, I'm going to turn it on. First thing I'm going to do to graph is I'm going to press that y equals button in the top left corner, and that gets me to this screen. So from here, I'm going to type in my first equation as I see it, 4 plus 3 over 2x. Whenever I have a fraction, I usually just do parentheses, so 4 plus parentheses 3 divided by 2 parentheses x. And then to type in my second equation, I'm going to press the down arrow, and then I could see that y2 is highlighted, and I'm going to type in my second equation. Now before I click graph, a habit that I like to get into is I'll press zoom, and then from here, sometimes I'll press zoom standard, because that will get you just your classic like negative 10 to 10 x and y axis. You also could press zoom 0 for zoom fit. This is basically just going to help ensure that when I actually graph it, my x and y axis are going to represent where my equations are going to go. So basically what I would want to see on the graph. So once I do that, I'm going to press zoom standard here, so zoom 6. And when I press the 6, it's going to get me right to my graph, and now I can see my system of equations. So from here, in this example, we're going to have nice whole number answers, so you might just be able to, on your screen, see where the coordinate would be right now. Sometimes we're going to be working with examples that have weird decimal answers that you couldn't just see with your eye what the coordinate would be. So if I wanted to find an exact intersection point, this is how I could do it in my calculator. I'm going to press second, trace, and that's going to bring me to this screen. Now I'm going to be using this list of options a lot, especially in the next unit when we're going to go over key features of quadratics. For right now, I'm going to focus on option 5, which says intersect. So I'm going to type that in. So second trace 5. And now I see this blinking cursor that's saying first curve. So how you want to think of it here is your calculator can easily graph things quicker than we could by hand, but sometimes you kind of have to guide it and tell it where to look. I'm looking for an intersection point, so from here I need to kind of move my cursors around to let my calculator know where I want it to specifically look. So what I'm going to do with this first cursor is I'm going to keep pressing the left arrow until I get to the left of that intersection point. Once I'm to the left of it, I'm going to press enter, and now it'll ask me for my second curve. And what I'm going to do here is I'm going to move that cursor to the right of that intersection point. Once I'm there, I'm going to press enter. For whatever reason it asks you to guess, just press enter again. And now it tells you your intersection point. So your intersection point here, or your solution, is -4, -2. Last thing we're going to talk about today is different types of systems that you're going to run into. So you can classify linear systems by the number of their solutions. So in the example we just did, we had one solution, meaning there was only one coordinate in which those lines intersected. We fancily could call that an independent system. Sometimes you'll run into two lines that are the exact same, so they're basically just overlapped onto each other. In that case, they have infinitely many solutions because they don't just intersect at one point, they intersect at every point. And finally, you might run into a situation where you have parallel lines, in which case they never intersect, and that would be no solution. We would call that an inconsistent system. So to end the day, let's talk about classifying a system and trying to do it without graphing. So here I want to know, is the system independent, aka one solution, dependent, infinitely many solutions, or inconsistent, no solutions. So I have my two equations. They're not necessarily in a uniform form where I can kind of make conclusions from it. So again, I'm going to get this into slope-intercept form. With my first equation, I'm going to move the 2x over, divide everything by 4, and I get y equals 3/2 plus 1/2 x. On my second equation, I have 8y equals 4x minus 12. All I have to do here to get the y by itself is divide everything by 8. And I'm left with y equals 1/2 x minus 3/2. So now that I'm in slope-intercept form, let's look at what I have and see if I can make a conclusion. What I notice first is that these equations have the same slope. So they're either the same line or they're parallel. So from here, they have the same slope, and while it might look like they have the same y-intercept, notice that in my first equation, I have positive 3/2, and in my second equation, I have negative 3/2. So these equations have the same slope, but different y-intercepts, meaning that they're parallel, or in other words, this would be an inconsistent system. Now, I would also recommend with these, try on your own to get these into slope-intercept form and make a guess for yourself just by looking at the slopes and the y-intercepts, how many solutions these would have. But on a test or quiz, I would highly recommend still graphing these lines into your calculator. If you see a picture, then that's another way to confirm what you're thinking. So if I were to graph these lines, I would see that they're parallel, and I would know for sure this is an inconsistent system.